Unmanned aerial vehicles, or UAVs, may look like typical toy airplanes, but this technology should not be taken for granted. UAVs are being used for a variety of different tasks, including law enforcement, search and rescue, and specific military operations. Currently, researchers in the Small Unmanned Aerial Vehicle Laboratory, or SUAV lab, at NASA Langley are developing unique UAVs to perform in high-risk situations that may be too dangerous or costly for humans. I spoke with Mike Logan at NASA's Langley Research Center to find out more.
Primarily what we're trying to do is solve problems for people. They will come to us with a particular problem, and we try and design and develop a small airplane to help solve that problem. In some cases, we may use brand new technology that we're developing here at NASA to incorporate in these small airplanes that help us to solve those problems. So they can come to us where they wouldn't be able to go anywhere else and get those problems solved.
So what kind of configurations do UAVs come in?
Well, as you can imagine, different problems require different solutions. For example, we had a group come to us and wanted a backpack observation vehicle where it could fit into a backpack. They could take it out, unfold it, and toss it in the air and fly it. It would radio back video images. In this case, the wings fold underneath, and this fits into a 15 by 15 by 5 inch box. Very light, very compact. We also test configurations before we actually make a flying model. This is a wind tunnel model of a small single-seat general aviation aircraft that we call the Channel Bug. It has these unique configurations called channel wings, and it lets this vehicle take off and land in a 50-foot runway. And of course, if you want it even smaller, then we have a smaller vehicle that would be capable of flying into a building.
And how is one of these created? What's the process that goes into developing a UAV?
Well, the first thing we do is we try and analyze the problem, and we use a lot of computer-aided technologies to help us with that. Once we get a design that we're happy with, then many times, for example, this is a mock-up of that same configuration. It was done using a process called stereolithography, where the computer divides up this model into little slices. It traces each slice onto a vat of photoreactive resin that hardens it. It builds it slice by slice, and then it comes out as a solid piece. So we can take this mock-up to make sure that it's going to be the right size and shape that we want, and then we can turn it into a flying vehicle by using those same CAD files, milling a mold to make the little skins for this vehicle, and turn it into a real airplane, similar to what you see here.
So what are some of the advantages that a UAV has over a regular piloted aircraft?
Well, there's actually a number of advantages that UAVs have over piloted airplanes.
One of which is the ability to fly lower, longer, and into more hazardous airspace than any pilot would dare. Much like robots are used to handle explosives in many police or SWAT situations, the UAV can be placed in high-threat situations, perform exceptionally, and complete its mission with little or no risk to human operators. With advances in audio and video electronics, real-time television images are possible to help guide a pilot around dangerous situations or gather valuable intelligence.
One of the problems we were presented with was a problem of trying to look at what's inside of maybe a partially damaged building. For example, in the case of an earthquake, you really don't want to risk a whole team of people going into that building, but you'd like to know if there's someone inside that you need to go rescue. So when presented with this challenge, we worked up a little prototype. That's what you see here. This is a little vehicle that would carry a camera. It takes off vertically. This is what's called a VTOL, or vertical takeoff and landing. Takes off vertically, wings pitch forward for forward flight, but then when it needs to hover, it can stop and hover. It can turn by moving the wings differentially. It can be flown by remote control by using a display that actually shows the picture of the camera in the nose. So you fly it remotely from the camera.
All without risking the pilot or anyone remote controlling the vehicle?
Correct. Another problem that we're looking at is trying to use these small unmanned air vehicles to detect forest fires. That's clearly a big problem. Finding and fighting forest fires now is very, very expensive.
The average cost of fighting forest fires in the United States is over $800 million a year. One reason that fighting forest fires is so costly is that by the time many fires are detected, they are already unmanageable. Although 98% of all forest fires are caught and extinguished quickly, it's the 2% that turn into wildfires, costing taxpayers millions. This is where the idea for the UAV comes in. The plan is to place hundreds of these low-cost UAVs on current or abandoned forest fire lookout stations around the country. The vehicle would remotely take off, land, and recharge autonomously up to 6 times a day from the lookout tower. It would travel over a section of the forest and use onboard sensors and cameras to detect smoke. If smoke is detected, it would send out a warning message to the Forest Service with the exact GPS coordinates pinpointing the fire. This would enable firefighters to respond much faster, potentially reducing firefighting costs dramatically. So Mike, what does the future hold for UAVs?
Well, we're looking at a whole range of activities and things that these small airplanes can actually do beyond just saving money, but defending our country, saving lives, solving problems. That's what the SUAV Lab is all about.